So today we are in lesson 7.5, the language of functions. And so I've thrown that word around without really defining it, without really talking about what it really means, just using it. Sometimes it seems like in the place of saying an equation, we say a function, and they are similar. Okay, but we're going to start using some different vocabulary to describe these equations, which we're going to start calling functions. So a function is a relationship between two variables in which the value of the first one is associated with, or it actually determines the unique value of a second. So that's our big idea. So a function is every x is paired with only one value of y. That's what determines a function. So you're going to see questions that say, is this a function? And so not every equation in the world represents a function. A function is when every x value only has one y value. So if I tell you x is 4, then there's only one solution for y, whatever it may be. When x is 4, maybe y is 5, or when x is 6, maybe y is 10. But if x can have two possible answers, so when x is 4, y could be 3 or negative 3, then that does not represent a function. So every x value can only have one y. Now we're going to talk a lot about input, output, which are similar to your independent and your dependent variables. So we want to make sure we understand that vocabulary. So an input is a number that's substituted for the independent variable. So we don't know what that is yet. But an input, if you just look at the word, you're inputting a number. Okay, and since that's the independent variable, let's jump down. A variable whose value does not rely on another, meaning that one is kind of the free variable. Any number can be put in, and you're going to substitute it in. You're inputting it. You're putting in, and that's actually going to traditionally be your x. So your independent variable is usually your x. If you've got an equation like y equals 3x plus 2, you're inputting for x. That's your independent variable. It doesn't rely on anything. You can put any number you want in. Where your output is what's produced, a number that is returned by a function. So you plug in something for x, you plug in an input, and then it creates a number here, and it now creates or outputs the y. And so your output traditionally is your y. Now we know we can kind of put variables as any letter we want, so technically could you move these around? Yes, the output will always be found here and the input will always be found here, but traditionally we see y by itself. That makes it the output because we plug in for x and it produces the output of y. And that's the dependent variable. It's dependent because y's value comes from whatever x creates. So we're plugging in an independent variable. That's the input. It creates something over here in the function, and then it's going to output your y. So your y is considered dependent on x because y is just a number created by x. So it depends on whatever x is. All right, we're also going to talk about the solution sets. Now, there's two different solution sets. There's your x's and there's your y's. And on a graph, your x's represent how far that graph goes left to right, and your y's represent how much that graph goes top to bottom or vertically. So your domain of a function is your set of x values. All the answers for x is considered your domain. We're going to use that word a lot, so you want to get used to it. And your range is your set of y values. So all the possible answers for y. Okay, a relation now is any set of ordered pairs. Okay, so any set of ordered pairs doesn't necessarily have to be specific to a function. All right, example number 1, we're just going to determine are these functions or are they not? So going back to the definition, to be a function, every x value can only have one value of y associated with it. So determine if this is a function or not. So if we look at letter A, we've got 3 different x values. Now they all have the same y value, but that is not the determinant. Each individual x value only has one answer. So this value of x has one answer. This value of x has one answer. This value of x has one answer. They can be the same, but each individual one has one. There is not 2 possible answers here for when x is 1. There's not 3 possible answers when x is 2, just 1. So is this a function? Yes. And when you explain, you can say each x is paired with one y value, or only one. So if we look at the second one, when x is 1, y is 5, only one possible answer. When x is 2, one possible answer. When x is 3, one possible answer. Is this a function? Yes, same answer. Each x is paired with only one y value. And so now let's look at the last one. So here we have three possible answers for when x equals 1. When x is 1, it could equal -2. When x is 1, it could also equal 4. And when x is 1, it could also equal 10. So is this a function? No, this would be an example of something that's not a function. X equals 1 is paired with multiple y values. So we're really stressing what a function is. Every x value can only have one unique y value paired with it. And we'll talk more on that, of course, later. All right, let's go to example number 2. We're going to consider this function. Remember, a function is the relationship between the x and the y, just for these values. So let's go ahead and make a quick chart. Normally we make these XY charts top to bottom. I'm just going to do it from the side. They want us to use these values of x. So 0, 1, 2, 3, and 4. And we're going to plug in for x. We're going to produce y. We've done this before. So if you plug in 0 for x, 0 squared creates the y. So we're inputting for x. The output is y. Inputting 0, and it outputs 0. If you plug in 1, 1 squared, y equals 1. If you plug in 2, 2 squared is 4, so y equals 4. Plug in 3, 3 squared is 9, and plug in 4, 4 squared is 16. So now we can answer the question. What is the value of this function when x equals 3? We've got that right here. Here's how we're going to write it now. So we want to get used to this. This says the function when x is 3. So we're going to be writing functions like this. It's called f of x. That's how it's read. F of x. So that's the function, and you're plugging in for x. So when x is 3, the function equals 9. So when you see f of x like this with parentheses, that's not multiplication in this case. When you see the f there, it's the function of. Okay, and when we replace the number in here, that's the number that's going as your input or your x, and we're basically looking for the answer. Another way to write this is y equals 9. So when you see f of x is actually equal to y, whatever y is. So the function of x, when you plug in for x, it's going to produce y. All right, letter B. The point 4, 16 is on the graph of this function. Which of these coordinates is the input and which one is the output? So the input is your x. That's what you plug in. You're inputting it. And then your output is y, because that's what's produced by the function. You input for x, it produces or outputs y. And so in this specific case, 4 is the input because it's your x. And I hope you see the 4 and the 16 comes from right there. 4 is the input. 16 is the output. When you plug in 4, when you input 4, it produces, or the output is 16. Letter C, which variable is the independent variable and which one is the dependent variable? So this kind of goes right hand in hand with the input and the output. X is your independent because anything can be plugged in for x. Y is your dependent because y depends on whatever is plugged in for x. You plug in any number you want for x, y is dependent on that. Y is produced by that x. Y doesn't make itself. Y comes from whatever number you plug in for x, creating whatever y is. So x is independent. And we can say that the value of y depends on the value of x. As x changes, so does y. All right, what's the domain of this function? Domain is all the possible x answers for this specific one. And so there's a new way of kind of writing this. So remember that this means all possible x values. And you're going to see answers written like this in brackets. So solving for x can equal 0, 1, 2, 3, or 4. That is your domain, all the possible x, and the range is all possible y values. So we're going to write this answer similarly. Your range is y equals, now it's just these possible answers. If you slide back down, these are the only answers for y in this specific function. And so it could be 0, it could be 1, 4, 9, and 16. So the key there is to just learn the difference between domain and range. Domain is all your x values, range is all your y values. Okay, sometimes these can go all the way to infinity one way or the other and include everything in between, and sometimes it's very specific numbers like this. All right, example number 3. Using the graph, determine the domain and the range of this function. Okay, so first of all, is this a function? Remember, to be a function, it can have only one x value paired with one y value. So for every x, you want to look up and see, is there only one y value? And we can use what's called the VLT, which is the vertical line test. And what that means is if you draw a vertical line anywhere on this graph, it should only hit one value of the function. So see how this only hits one value, one value, one value? So yes, this is a function. Now, why does that work? Because at this vertical line, x is 3, and we're showing there's only one possible answer to the function, one possible y value. This vertical line is x is 6, and it only has one possible. So let's say that randomly there was other points here, and this zigzagged, or there were just free points like this. Now, when x is 3, there's actually more possible values of y than just one. So this would not be a function once I start adding these extra values here, because when you draw that vertical line, you see more than one possible answer. But for the original function here, when you draw a vertical line anywhere on this graph, it only hits the function once, which means there's only one specific or one unique value of y for each one of these x's. So now let's answer the question. They want the domain and they want the range. So this time we're going to write them, instead of listing every single one, we're going to say the domain is between these two numbers and the range is between these two numbers. Because if you look, if you were going to list the domain, which is your x, so let's start there. If you just said x is 1, 2, 3, 4, 5, 6, 7, 8, you're not counting everything that's in between. So that would only be if I had single points on each one of these. But since this is a line, all of that is part of the function, all is part of the solution. So everything between 0 and 1 is a possible answer. Everything between 1 and 2 is a possible answer because that line exists there. And so when we write our domain, we have to include those. So we're going to write it like this. X is everything greater than or equal to 0, because that comes from right here. And everything less than or equal to 8. So not just the whole numbers between 0 and 8, everything, including your fractions and your decimals. And so we're going to list it like this. And our range then, if you look, is everything from 0 to 4. Everything in between. You've got partials, you've got halves, you've got 3/4. It's not just the single 1, 2, 3, and 4. Okay, it's everything in between. So when we list our range, it's your y values, and it's everything greater than or equal to 0 and everything less than or equal to 4. So if you need to include numbers besides the whole numbers, this is how you're going to have to write your domain and your range. Okay, last example. Kind of now we're going to apply everything we just learned. On the graph on the right, it shows the amount of money Jenny spent on clothes the last 6 months. So as every month passes, you can see how much money has been spent. Find the value of the function when x equals 5. Okay, so you're going to find x equals 5 and follow it up. Now the way we write that is like this. the value of x when it's 5 produces what answer? The function when x is 5 is, and then just go find your answer. You follow 5 up, and it's 200. Remember, this is what y equals. So y equals 200 when x is 5, but this is the way we're going to write it when we're talking specifically about a function. F of 5 is 200. Find the value of the function when x is 3.5. So f of 3.5 is, so where's 3.5? Right here. Follow it up. It's 150. So f of 5 equals 150. The value of the function when x is 3.5 is 150. All right, find x now when the function is 50. So f of x equals 50. So that means y equals 50. We're trying to find x. Okay, so where is that true? When y is 50, so go to your y, follow it over. Y is 50 when x is 1. So we know f of 1 is 50. So x equals 1. You could write it this way and you could write it this way. So basically we're trying to find out what's x when the function produces 50 or when y is 50. So f of what is 50? F of 1. When x is 1, it's 50. So I think finding those numbers on the graph is super easy. It's just getting used to the new way of writing things in the vocabulary. Now, what's the range of this function? Remember, range is all possible y values. So if you look at it, y values from top to bottom, we're going from here to here. And it's everything in between. It's all connected. There's no breaks. It's not just the whole numbers. It's not just 50 and 100 and 150. It's everything in between because it's all connected. And so we're writing this as our y values. It's everything from 0, so everything greater than or equal to 0, and less than or equal to this top number, which is 225. Last but not least, what's the domain? That's your x values. We write it like this. X is also everything in between 0 and 6. It's not just 1 and 2 and 3 and 4 and 5 and 6. They are connected, and so everything is included. And so we're going from 0 all the way up to 6. One thing we didn't talk about here, we just assume this is a function. If they asked you, is this a function? Remember, you can do that vertical line test. If you draw vertical lines, are you only hitting one point on that function? And the answer is yes. This passes your vertical line test. This is a function.